I'm going to keep this straightforward because I know a lot of you are standing at the crossroads of, do I need a power quality analyzer? And, is this the one that actually helps me avoid costly downtime? What I'm about to walk through is the kind of practical, day-to-day reality that decides whether the FLUKE 5126630, the model 1777, ends up on your bench or in the drawer. Link is in the description if you want to check the product details on Amazon. First off, the hesitation is understandable. A power quality analyzer isn't something you grab on a whim. It's a tool you pull out when you're troubleshooting flickering lights, intermittent equipment failures, or trying to justify an upgrade to a UPS. The biggest risk is buying a device that either overwhelms you with data you can't interpret, or one that falls short when you need to capture a fast transient that's been dragging your system down for months. So, before we get into the nitty-gritty, let's frame the problem. You need to know what's happening on the line, you need to trust the numbers, and you need the data to be accessible when you're trying to explain the issue to a manager or a contractor. Who really benefits from the FLUKE 1777? Think of a small to mid-sized commercial electrician who routinely services office buildings, data centers, or manufacturing floors. Those folks often have to diagnose voltage sags, harmonic distortion, and momentary interruptions that aren't obvious on a standard multimeter. The same goes for facilities managers who are responsible for maintaining compliance with power quality standards like IEEE 1159. For them, having a handheld unit that can log waveforms, generate reports, and store data for later analysis is a huge time saver. If you fall into that category, if you've ever tried to explain why a server kept rebooting and the only answer was maybe a power glitch, this analyzer is built for you. Now, who should walk away? If you're a homeowner who only ever checks that a breaker isn't tripped, or a hobbyist who's looking for a cheap way to measure a single voltage reading, you'll likely find this tool over-engineered and pricey. The learning curve is real. You'll spend a few hours getting comfortable with the interface before you can confidently set up a capture for a specific event. In that scenario, a basic clamp meter or a data logger with a single channel might be a smarter investment. Let's talk about practical strengths. The first thing most users notice is the way the unit handles data capture in real environments. I've spent time on a manufacturing floor where three-phase machines were running, the lighting was on a dimmer, and the HVAC system was cycling. Plugging the FLUKE into a single phase, I could watch the voltage waveform in real time and immediately see a recurring 0.3-second dip that coincided with the compressor kickstarting. The device logged that dip, flagged it as a sag, and gave me a clear histogram of how often it occurred. That kind of visibility turns a mystery into a documented event you can hand to the building engineer. Another strength is the reporting workflow. After a capture session, you can generate a PDF report directly from the handheld. The report includes the waveform snapshots, statistical tables, and even a quick interpretation of whether the event meets typical standards for sags or swells. For a contractor who needs to bill a client or for a facilities team that must keep a log for compliance, that built-in reporting cuts out the need for a separate laptop and software suite. The analyzer also shines in its ability to capture fast transients. Power spikes that last a few microseconds can be invisible to most instruments, yet they're the culprits behind premature equipment failure. In my testing, the FLUKE recorded a 5 microsecond overvoltage caused by a nearby lightning strike, something I'd never been able to see with a cheaper logger. That kind of fidelity is where the value truly comes from preventing a costly replacement by catching the event early. On the flip side, there are a few practical weaknesses to flag. The first is battery life. When you're running a long-term log, say, a 24-hour capture of a building's power profile, the unit will drain its internal battery faster than many users expect. You'll need to have a spare pack or keep it plugged in, which can be inconvenient if you're trying to monitor a remote panel. Second, the menu system, while comprehensive, can feel dense after a while. The device offers dozens of measurement types, and finding the exact configuration you need sometimes means scrolling through submenus that aren't intuitively labeled. That's not a flaw in the hardware, but it does add a step to the workflow that you have to budget for in training time. Another trade-off is the cost versus the depth of analysis. The FLUKE 1777 sits in a price tier that assumes you'll be using the advanced harmonic analysis and flicker measurement features regularly. If you only need basic voltage, current, and frequency monitoring, you might end up paying for capabilities you'll never touch. In practice, many electricians start by